this cloud computing, and all of the material for the course is supplied on my own personal website. I find it easier to maintain stuff in a web space. I control myself, and from Mole that points to this page here, so you can come here and download the material. So all the lectures are listed down here in PowerPoint on that side, and on this side they're printed sort of two up as PDF slides. I would say it's worth downloading the PowerPoints because some of them eventually have videos and animations embedded in them, so you can play those and run those. And as we go on, you'll find that we've got a number of self-study labs. We'll have a lab class Fridays. I think in the middle of the morning in the Diamond, and there'll be a number of sort of life skills classes in learning how to use Linux, how to build basic websites with programs that run at the back of them using a sort of older technology, just to get you used to doing this. And then we'll move on into sort of Java servlets and cloud servlet deployment, which is what we're going to be doing. One of the other things that you want to think about is the major assignment for this module, the major assessment, is a group project. And to take part in that, you will need to sign up for a team. And there's a little web form here, which is highlighted. Team sign up. This allows you to put in the details of you plus a preferred partner. So in the Faculty of Engineering, the rules for making up teams aren't that you choose your whole team, but you can choose one preferred working partner, and then after that I have a sort of random algorithm that assigns people to teams. These hopefully should work. Let's see, if I submit with no data, it should actually give me error message. Yes, that's correct, good. So that program is working. And as you go on, you'll eventually be able to see who the teams are by clicking on this link. At the moment, there's obviously no one in any teams. And as we go on, we'll be releasing different parts of the project. So I quite like everyone to have got themselves organised into teams by Friday of week 3. So this is week 1 of teaching. You've got 3 weeks to think about, 2.5 weeks. To think about who your partner is going to be, submit that, and as you do that, periodically I'll run the algorithm that forms up the teams. So you'll see that within maybe 2 or 3 days once you've submitted your pair. And then we'll release in week 3 the first part of the project, unless it's already there. Oh yeah, no, the first part is already there. So you can see that. And the first part will be due Friday, week 6, and I'll say a little bit more about that as we go on. So that's the schedule. Welcome to Cloud Computing, and I'll get on with the first lecture. Okay, so the lectures are a strange mixture of general business information about what the cloud is and what's going on in the cloud, and a set of sort of technical instructions about how to construct your own cloud platform using standard Java technology. We settled on Java technology rather than anything else because Java technology is what all of the SSIT students are using. And this module is predominantly taken by master students on the SSIT course. We do have a small number of fourth-year undergraduates. Again, if this turns out not to be the flavour that you want to do, then you have the choice of making the switch. I guess I'm speaking mostly to undergraduates, but this module is predominantly Java, and it uses sort of web standard Java technology that's used all around the world. I've recently finished a cloud computing industry project with companies in Germany, and they use Java, Tomcat, Servlet, and all of that technology in Germany. So I got a number of suggested background reading things. You don't have to look at those, but I'll highlight the relevant books for each lecture. Thomas Earle's one is the one that gives you a good sort of overview of what cloud computing is all about. And then we got, they go through books that describe different aspects of cloud computing, service models, how do you make money in the cloud. Then particularly this one, Amazon Web Services for Dummies, if you want to sort of mount your own business on Amazon, how to do that. Today we're going to be just looking at some very general introduction, trying to find out what is cloud computing, because it's a buzzword. Do we understand the right thing? We'll have a look at a number of things that cloud is and a number of things that it isn't as well. So we're going to define by a sort of a dialectic method by saying this isn't cloud computing, it's something else. So we'll come up with what the characteristics are. We'll have a look at what are called the different cloud service models and different kinds of cloud that are out there. We'll have a look at what's in the cloud and what the sort of prospects are for the cloud going forward. Here's an interesting one. Does anyone remember the Adventures of Professor Brainstorm? There's a wonderful cartoon stories about a little, a funny guy, and there was Edward Robinson, who was known as Edward Heath Robinson, who created all the cartoons for Professor Brainstorm. And here's a notion of a man who's living, I suppose, in an early version of the cloud. He's sitting out there. So we'll have a look at that. So what the cloud isn't, we'll think about this. It's not the internet, it's not data centers, it's not online working, it's not grid computing, it's not service-oriented computing. So all of these things are different, and they're not quite what we mean by cloud computing. So let's have a look at some of these. Does cloud computing mean working online all the time? Okay. So for example, we now have all our mail or chat online through, say, Gmail, all these other ones. Is it the fact that we now store most of our data somewhere online, such as in Dropbox, or our pictures in Flickr, or stuff in OneDrive for Microsoft, or iCloud if you're an Apple user? Is it the fact that we now conduct a lot of our business online, buying things via PayPal or eBay, downloading our music, even doing supermarket shopping via Ocado? Is it the fact that a lot of our social life is now online? Facebook, Twitter, LinkedIn, all of these things. Is it the fact that we can now live in a virtual world online with massive multiplayer online role-playing games? That's what that's called, with things like Second Life or World of Warcraft, very popular. No, those things are not what constitute the cloud or cloud computing. Does the cloud mean it's because we've now got lots of integrated software? So for example, at the university we use a Google Office suite with things like mail, calendar, contact lists, and so on. Computer-supported cooperative working. Google Groups, Google Sites, Google Drive, where you can now sort of share stuff selectively with your working colleagues at different levels of security. Or other kinds of things, such as Google Maps, Google Translate, bloggers, and things like that. Is it that you can integrate sort of services across different devices? So, like on Apple, you've got the Mac, the iPad, the iPhone, and you can do a lot of the same things on each of those things. Is it that you've got shared services across different platforms, like iTunes, App Store, or the Apple iCloud? Is it, say, in the Microsoft world, the fact that now in Windows you have one sign-in system that gives you Windows 8, well it's now Windows 10, isn't it? OneDrive and Skype, you have to sign in and you get all of those things. Is the cloud the fact that all of these things are integrated? No, not really. Is cloud computing the fact that everything that we do is now distributed, it's run at different sites? So we have this notion of distributed computing. We've got centralized databases with the benefits of scale. We've got physically distributed nodes, which is attack-proof. You may know that every major bank in the UK, by law, has to have 3 different geographically distributed data centers to protect all of your banking information in the event of a serious attack, a nuclear strike. Is it the fact that all the networking is secure? We've got data replication and recovery, something called RAID, which is a standard for replicating data. It stands for the redundant array of independent disks and is a common way of storing data safely in various ways. What is RAID? So we'll look at that. So there are different RAID standards. RAID 0. That's called data striping. What does that mean? Data striping is where you don't store your file as a single block on the disk. Instead, the disk is cut up, as it were, into lots of individual segments where files are distributed over different segments. So the different slices of each file are called stripes. And data striping means that the data from your one file is stored in a number of different locations on the physical hard disk. The reason for doing that means if there is a physical defect on any one part of the disk, it won't impact all of somebody's file. It will only affect a tiny part of one file. Then there's a standard called RAID 1, which is where we copy the data from one disk and make a duplicate copy on another disk. This is known as mirroring, creating a mirror image of the disk. And there are various standards of RAID. This goes up to RAID 5, where you've got block level striping, distributed, parity checking, many drives, and so on. And you can combine these. You can have RAID 0+1, where you've got one striped disk and a second mirror disk that copies the first, and so on. And you can also have RAID 1+0 the other way around. You can create a striped set from mirrored drives. And each of these different ways of storing data in a distributed way make your data safer because there's more copies of it. If you've got parity checking added, it means that you can actually detect whether or not the data has been corrupted. And you often have a means of recovering the original data from several different copies of broken drives. So it gets more and more secure the more of this that you have. So is the fact that our data is now stored in this distributed way, is that what defines cloud computing? No. What about grid computing? I guess you've heard of grid computing. It's where people build big compute nodes for processing vast amounts of data, doing lots of calculations in parallel. This would be something, for example, that the students who are doing the MSc in data analytics would be using as a matter of course. They'd be running programs on the grid to do complicated machine learning algorithms. HPC, high performance computing, HPC, is a way of having massively parallel networked compute engines. And the architecture that they build is called MapReduce, which is rather like, this will make sense to the undergraduates. MapReduce is exactly like functional programming, where you have a mapping function that applies a function to every element of something else, and reduce is exactly like the reduce function, where you combine the results of processing from a list of things. But of course, in this context, MapReduce is being done on parallel architectures. So you're taking a massive data processing problem, you're splitting it up into an array of identical subproblems, and then you're causing the processing algorithm to be distributed, to be mapped across every single subproblem, and each of those subproblems is computed in parallel. Then some reduction operation happens to combine all the results together in a final result. And this has given rise to an architecture that was nicknamed Hadoop. Apparently Hadoop is a cartoon elephant, but Hadoop is the name of the software system that's used to do this distributed processing. You may have heard of things like MIMD and SIMD. SIMD, single instruction, multiple data. And so grid computing is good for that kind of number crunching. where you've got a single program which has to be applied to vast amounts of data. That's grid computing, so it's a way of speeding up big calculations. There we are. So again, what's it do there? We slice big data. We've heard of this buzzword, big data. Slice it into chunks, so it's distributed over n processors. Performs the same operation in parallel over each chunk, and then it recombines the results afterwards. And it restricts the class of algorithms to those that you could do with single instruction, multiple data. It's a static architecture. It's predefined, so the layout of your hardware, the layout of your problem has to be defined statically in advance. Is that cloud computing? No, it isn't. It's something else. So is cloud SOA, service-oriented architecture? Okay. In recent years, well, since I suppose 2000, people have been talking less about programs and talking more about services. And what do people mean when they say that? Well, it's to do with the fact that older enterprise programs are being somehow turned into software components that then can be wrapped up in a sort of internet layer and offered online. ERP, enterprise resource planning systems, the kind of financial systems that you would have in John Lewis's, Debenhams, Marks and Spencer's, these sorts of shops. There was a big drive since the 2000s to convert all of these things into, online enabled applications. And service-oriented architecture involved some standard web communication protocols, such as the Web Services Description Language, which we just refer to as WSDL, I guess, or the Simple Object Access Protocol. And these are the XML descriptors of pieces of data that you transmit via the internet using the WSDL interfaces. So WSDL describes interfaces, SOAP describes the data packets, and then you have a system of discovering web applications through the Universal Directory and Repository API, which has been deprecated since. And then you have a means of composing services together online, and they call this orchestration, where it's where one process has the control, like a conductor, over how the related services are linked together. Or else they might call it choreography, where the services all execute in parallel without any central control, but manage to exchange data with each other at the right time. And this kind of thing can be described to another web standard called the Business Process Execution Language, known as BPL. Okay? So all of this constitutes a paradigm for online systems offered as services that can be recombined and plugged together, that can be discovered automatically, and that it's all done through a layer of web wrappers and with programs implemented in your favorite programming language, whatever, behind the scenes. And altogether this forms what's called service-oriented architecture. And is that the cloud? No, it isn't. It's not the cloud either. So there are all of these things which aren't the cloud. Is the cloud all of these things put together? That's an interesting question. Well, cloud computing does require the internet. It requires online communication. It does require integrated cooperating systems. It does require secure distributed data centers. It does require some available processing power to do all the kinds of things people want to do. It does have a kind of service-oriented philosophy as well, and it does need suitable programming APIs for you to interact with the cloud. But they themselves don't constitute the cloud. Consider all the above as the enabling technologies. In other words, the cloud could not have arisen without all of these things, but in and of themselves, they are not cloud computing. Okay? They are not cloud computing. They're the background to cloud computing. So we now move on. What actually is the cloud? What is it? What makes it cloud computing? It's this. It's virtualized resources. It's shared resources. It's elastic computing. It's arbitrary scaling. It is a utility consumption model. These are the things that define what we mean by cloud computing, and it's on demand as well. So these are the things that make it cloud computing. So where does this phrase, the cloud, come from? Rather fanciful thing, the cloud out there, you see. Originally, this cloud symbol used to be in internet wiring diagrams where they wanted something to stand for out there, the rest of the internet. Okay, so here you have an early example of your within office routing system where you've got some computers, you've got some switches, you've got a server, and then another router that somehow connects to the rest of the internet out there. And so that's where this little cloud symbol first came from. So about as early as 1994, that's where that came from. The name cloud first appeared in a memo written by the now defunct company called Compaq. It was an internal memo on cloud computing. I've got a copy of that memo. I think you can download it, yeah, have a look at it. This guy, George Favalero, who was a Compaq marketing executive, produced the first ever known print reference to cloud computing. And his idea was, that in the future, all of our processing will be handled somewhere remotely. But before that appeared in print, in August of the same year, Eric Schmidt, who was the chief executive officer of Google, actually defined in a conference speech what he thinks cloud computing was going to be like. He said, it starts with the premise that data services and architecture should be on servers. We call it cloud computing. They should be in a cloud somewhere, and that was as part of a search engine conference. There's the same document that he's holding now. So that's how the term cloud computing was coined. What was the first sort of true instance of a cloud? Well, Amazon launched something called the Elastic Compute Cloud in 2006, and this popularized the use of the term cloud. It was the first to offer dynamic and scaled resources. So this is the idea, Elastic Compute Cloud. You've got some server resource, you could add another, and build it together. The features of Amazon's Elastic Compute Cloud were this. You could auto-scale your resources. You could either increase or decrease the capacity, the computing capacity you were using. It offered what's called elastic load balancing. Load balancing is where the system decides how to disperse traffic over multiple instances of servers. It was distributed, it was in multiple locations, all of these places, Virginia, Oregon, California, Ireland, Singapore, Tokyo, Sydney. And there was a system of monitoring the usage, so something called CloudWatch, which is another Amazon system that was monitoring which of these servers were being used. And there was something called the Elastic Book Store, which was a way of storing block storage, file storage in Elastic server volumes. So you could have another server to store your data if you had even more data. So this was the first instance of something that behaves like what we now understand the cloud to be. But we can trace the sort of origins of the cloud to a number of historic milestones. So, for example, there is a company called Salesforce. If you're in any kind of form of business with sales and customer management, you probably have used Salesforce software. They were the pioneers in online human resource management or customer relationship management, sales and software via the web. They started out, as a software company. They just sold products that you installed on your computer, but then they moved to the web and they sold applications online. These kinds of products were very, very useful for new companies who wanted to be able to manage their human resources or manage their customer relationships. Then in about 2002, Amazon came up with what was called Amazon Web Services. This wasn't exactly cloud computing as I just described on the previous slide, but it was really a way of providing basically servers online. Web Services provides what we call infrastructure, which is the sort of the low-level stuff, the hardware, the data storage, and so on. Storage and computation, a sort of marketplace for workers to use. In the second lecture, we'll describe how this came about and why Amazon turns out to be a big player in the cloud. And then it was only in 2006 where the Elastic Compute Cloud came out, the thing that we had on the previous slide, and also something called the Simple Storage Service, S3, which was Amazon's sort of elastic data storage system. And this was the first time that your customers could rent computer space and run our own applications in this rented computer space. Let's say Google in 2009 with Google Apps, where they suddenly integrated Google Mail, Google Sites, Google Drive, and Google Maps, and all of these things. Suddenly, this became a kind of a little ecosystem of applications that could be run remotely. Now, America has this National Institute of Standards and Technology, NIST, and they have now provided a proper definition of what cloud computing involves. First of all, it must be on demand, and this is a key defining property. You obtain servers that you need, CPUs to do processing, operating systems that you want, data storage as needed. You command it that way. Then it must be accessed by a network. It must be able to be accessed through all kinds of things: phones, tablets, laptops, PCs. Resources are pooled. That means that there's one big pool of hardware and compute resources which are shared by different users at the same time. And we have this concept which is called multi-tenancy. So a multi-tenancy is like multi-user usage, but on a larger scale. If I describe a tenant as a whole company, like say John Lewis, multi-tenancy would mean that multiple companies, John Lewis, Marks and Spencer's, Debenhams, were all using the same hardware, the same physical resource. And within each company or tenant, there are multiple users. So multi-tenancy is basically like multi-users writ large. Okay? Then they have to be elastic. Okay, the resources have to be elastic, which means you need to scale in and out commensurate with demand. As demand goes up, you provide more resource. As demand goes down, then you free up resource. You shut down equipment. You save the energy to run it. And finally, it must be measured. So this means that every time you use cloud, something is monitoring your usage. It's measuring how much bandwidth you consume, how much data storage you're using, how much processing time you need to do your calculations. And the notion is you're charged for this. You're metered, rather like a utility company for your electricity, your gas usage. Cloud computing is the next utility, like gas and electricity. Now, within the cloud, there are different service models, different ways of offering a cloud service that could earn you money. The first is infrastructure as a service. So you might say this is the entry level to cloud. This is the lowest level of service you can provide. And I've shown there a number of the common providers who offer these things. Infrastructure as a service is where instead of having to have your own servers in the basement of your company, you rent out servers from, let's say, Amazon or IBM. And these products, Amazon Web Services, is just basic, servers out in the cloud. IBM has a product called SoftLayer. Rackspace is another company that's very well known for providing infrastructure services. The next service model is called platform as a service. These various kinds of acronyms, they have these little acronyms like IaaS and PaaS, like that. A platform is where not only do you have the servers out there, but you have a layer of other software and apps that you can use, that you can consume. So they don't just provide the raw servers and data storage, they also provide a collection of common software applications, which we now know as apps. And here, for example, Microsoft Azure, the Google App Engine, Zoho, Heroku, you may have heard of these platforms. So it's where you've got infrastructure plus some applications. But the idea about this is that you can still build your own applications on these platforms that possibly integrate with other applications which are already provided. So for example, a common thing would be to build some business-related application in Google that perhaps integrates with Google Maps, so you can then show your customers where you are in a Google map, you see, or something like that. And then the sort of the top service model is software as a service. This is where basically you provide everything from the infrastructure, the platform, through to complete finished solutions ready for your consumers just to use out of the box. So the Google Apps collection is something like that. Salesforce, is the you might say the leader or the key example of a company who made their entire business out of selling a ready-made sort of financial products to help the company run its business in the cloud. So those are the three levels: infrastructure, platform, and software as a service. Those are known as different cloud service models. So that's the different kinds of service you can have. Now there are also different kinds of cloud. Okay. What we have here, for example, is what we call a private cloud. We have something that we run as a platform, as an infrastructure, as a service, and that's hosted by us internally for its own needs. IBM do this. Many years ago, they decided to rationalize how they provided servers within the company, and they moved all of these into a number of data centers that was accessed only by IBM software, by IBM customers. So it's a way of offering cloud services within a company using private resources. Then the sorts of cloud that we kind of run into, hear about on a day-to-day basis, are what are called the public cloud. So Amazon, Google, Rackspace, and so on offer cloud resources that are open, to anyone who wants to hire a resource from them. So that's an open one. There's something called the hybrid cloud, and this is where you have a mixture of a private cloud resource and then, where you can migrate into the public cloud, where your resource needs are exceeded. You have too much work, you need to burst out. And they call this cloud bursting, again another rather colourful metaphor, like a storm breaking. Why would you do this? Well, let's say if you're a company like Rolls-Royce, a lot of what you do is very, very secret. You don't want to give away any of your business secrets because you're the world leader in producing jet turbines. So a lot of this stuff can't go out of the company, and therefore it has to stay, in a private compute data storage place. But there might be other aspects of the business which are not so secret, and from time to time, when the resources are busy, doing lots of simulations of jet engines, say, then some of this other business could be transferred out into, let's say, an Amazon cloud or something like that. If it's less critical, less secure. So hybrid cloud is of interest to companies that have a certain amount of proprietary information that they want to keep private. Then let's say you're a charity and you work with down a town centre with a number of other small organisations. You can create what's called a community cloud, and this is where instead of running your computers just for your own little charity or something, you pool your resources together and you create a cloud for a community with similar goals, and that's another nice idea. Finally, there's something called a federated cloud, which is basically any other kind of collecting or joining together of pooling of multiple public and private clouds. So these are different kinds of cloud setup that you can have. And so here we have a kind of nice image of everything that constitutes cloud computing. We have out here in the cloud, we have some infrastructure where we've got computers, we've got some storage, we've got our networking facilities. On top of that, we've got a platform where we've got, the runtime system, queues waiting to put jobs, databases which different customers can use for their different projects. Identity checking, so single point of sign-in when you log into the platform. Object storage when you store the information that different people have done. On top of that, you've got the various applications. We could have different kinds of static content, collaborative applications to help people work with each other, communication systems, financial systems, and then a monitoring dashboard here that actually shows just how all of these resources are being used. And then it's accessed from outside via all these different things, different servers, laptops, phones, tablets, desktops. All of these things can go in and make use of the shared resource in the cloud there. Here's a few cloud statistics from a number of sources. So in 2013, that's going back 5 years, 6 years now, the S3 simple storage system contained 2 trillion objects. Okay? And if you think about that as an interesting figure, well, the Milky Way, our galaxy, has 5 billion stars. So that means we've got 5 objects stored per star, which is a lot of stuff, a lot of data. And Simple Storage Service then received 1.1 million requests per second. The scale of this is huge, and that was only in 2013. In 2015, we had over 1 exabyte of data now stored in the cloud. That's over 1 billion gigabytes. Okay? 2016, the prediction was that users would then store over 1/3 of their data in the cloud. You can think now how much of your data is in the cloud. You know, your photographs, your images, your shared work. The 2018 prediction was that more than 60% of enterprises would base at least half of their infrastructure in the cloud. So it's kind of massive. I mean, the huge shift into cloud computing. And we'll be looking at why that is the case. Why is everyone doing this? If you have a look at different providers, well, I just kind of, these next couple of slides sort of like flashcards showing you a number of different providers. There's Amazon Web Services. What do they offer? This cloud platform for storage. It's good for businesses. It's very available. And very scalable. And it's not good, if users are seeking sort of open source or operating without internal management. Microsoft Azure, that's grown hugely in the last few years. That's both infrastructure and a platform for development. And it's kind of good for enterprise clients who are already familiar with Microsoft products. So things sort of appear on Azure roughly in the same way as they appear on Windows 10, you see. So they're trying to converge towards a similar way of dealing with things. Not particularly good for people who are unfamiliar with Microsoft or people who want to sort of manage cloud. The Google Cloud Platform over here, that's of course familiar to most of us at the university, where we have different products and technologies hosted by Google. And it's good for people who are seeking a sort of streamlined cloud ecosystem for development and management. You can add further apps into it. It's if you want to do your own building on top of Google, that's one of the good things you can do. It's not good if you're seeking a completely managed cloud platform, or if you just want to do simple cloud tasks, because it is actually a little bit complicated to use the Google Cloud Platform. Here, the IBM cloud, they call it Blue Mix. This is a multifaceted cloud for business. It's pretty good for business users who are seeking bare metal infrastructure. It's if you want to install the IBM way of working on your own distributed hardware, and so you can do that. Again, it's not good for minimal cloud functions or simple storage and computing needs. It's kind of organized around business operations. Rackspace, they were one of the first companies to offer out these dedicated servers and infrastructure services. It's a very strong sort of managed hosting with a number of managed, mostly data storage related services. So not so good if you want a complete cloud ecosystem with all sorts of apps and things and so on. Red Hat, another famous sort of provider. They're very much into open source technology, so they use all of the open source material. The thing about with these open source companies is it is free, it is open, you can do it, but then it's so difficult to use that you have to hire them to actually help you run the thing because it is very, very complex. It's open technology for enterprise clients. It's good for users who prefer a sort of open source Linux, open source networking type of systems. Not good if you want a sort of turnkey service with complete set of cloud services and tools. So there are these slightly different types of offering, and they're aimed at slightly different groups of people. And you need to pick one that you can use. So, what's the structure of this module going to be like? Well, it's going to combine a number of different things. It's going to combine some knowledge about what the cloud is, service models, business models, how do you make business in the cloud, I suppose. It's going to involve practical skills where you get to build and deploy your own web services platform in the cloud. So basically we're going to be using a private cloud infrastructure. So this is where we have 4 servers that are networked together in a cloud, running a cloud called Open Nebula. And that provides you with server infrastructure, and in your teams you'll be building a cloud platform, so you'll be building the next level on top of that. And we'll be using a Java model, so that is Linux with Apache web servers, Tomcat web server, Java servlet technology, which will be explained as we go through the course. And for many of you, this will be the most complicated piece of programming you've ever done, because you will need to wire together a lot of different technologies. You'll need to understand the web and HTTP. You'll need to understand Java, Java programming, Java servlets at the back end. You might possibly want to connect to a database, so you'll be using maybe MySQL as a database behind that. And there's a big learning curve. Okay, we try to help you get there, but be prepared. There's a lot of learning, and you'll make a lot of mistakes. And again, I make no apologies that we're running the sort of standard Java approach to doing this, since this is the approach that most of the students here are able to tackle. We will assess you in teams of 4. The idea is you will have to pitch a sort of product, pitch a different collection of apps first, and then build it later. And after week 6, well, is it after the Easter vac or before? I'm not sure. I think it's before the Easter vac this year. You'll get some feedback on your initial demonstration to see whether you wired the technology. So by the end of week 6, we expect you to have connected up your presentation layer, your processing layer, your data storage layer, and send something in and fetch something back out. Okay. So just prove that you can plug all the layers together by that time. And then there's a final report during week 10, which is where you deliver your team's software. And you deliver a report about it and the whole software. And then in week 11, every individual student gets to test the system of another team. So we create a test schedule in the form of a questionnaire, which the testers individually have to work through and run some other team's cloud through that test schedule. We ask you to do certain interactions and fill in a questionnaire as you go. So that's how it works, and this is the way we're going to do things. So this is why it would be useful if you sign up. Find a preferred pair partner. Make sure you've agreed with that person before you sign up, right? I don't want to have like the same person entered into 2 pairs. If that happens, then it blocks the team formation, and we have to say, sorry, we can't do this until you made your mind up. Check with your partner who you want to be with, and then as we go along, I'll start forming up the teams. So to summarise, the modern cloud grew out of access to services via the internet, distributed data centers, integration of different kinds of service applications. Key distinguishing features are it's on-demand access, resources are shared by multiple tenants, there's elastic resource consumption and scaling, metered usage and pay-as-you-go charging. And there are many, many cloud providers out there. You have a choice of sort of managed clouds or build your own setups, different focus on business work or developer interest or hosting for you, sort of thing. Now, the last thing I have to do today really is for, I think, the fourth year undergraduates, which is the National Student Survey. I've been asked to popularise and say, please fill in the National Student Survey. Okay? As you no doubt know, this is something that's conducted independently by the UK government, and students are able to say what they've experienced in their whole undergraduate programme. There we are, it's an annual survey of mostly final-year undergraduates, commissioned by something called the Office for Students, OFS. It's conducted independently by Mori, which is a pollster company. It's allegedly quick and easy to complete. There's the website for it, so I'm advertising that. You could even scan this QR code with your smartphone and go directly there. And so I'm encouraging final year undergraduates to complete that. The more we get, the more likely we are to be included in the national statistics. So we need to hit a kind of critical number of responses in order to do that. Okay, I think that's all for today. Thank you. And tomorrow